Now let's look at the choroid. So what is the choroid? Again, it is a continuous layer, but with that uvea. But you have these little projections right here, and these are what you call ciliary bodies. And notice that they're kind of throwing these little threads over here toward this lens of your eye. So what are these projections? These are called ciliary processes. And then what we have here are suspensory ligaments. So they're these little protein fibers that help to keep your lens in place. So what we're actually seeing here is a cross section. It's not just like a simple flat uh, bridge right here. And what we have here is the lens. So let's take another look at this sort of structure. And I don't think this is actually in either textbook, but your lens is round, and the ciliary muscle, which we saw in cross section before, is actually a round ring of muscle, and it's different from the muscles that are in your iris. It's actually something else with all these ligaments that attach to the lens. So the interesting thing about the ciliary muscle is that it's a ring of smooth muscle, but remember, muscle, what happens when it contracts? It shortens. What happens when you shorten a round muscle or circular muscle? It constricts. So this is an interesting thing. This ciliary muscle this is connected to the lens by all these ligaments. So when this muscle constricts and changes shape or relaxes and then gets bigger and thus making the ligaments more taut, it actually changes the shape of the lens, despite being pretty hard. And I wish we had in normal circumstances, we've had in-person labs, but this lens is pretty hard. It's made out of these crystalline proteins, but it is still flexible. And that's actually, so it is a type of tissue. It's not like or when you think of lens, you might think of a glass lens. It is hard, but it is flexible, and it is able to change shape based on the ciliary muscle and all these ligaments. Okay, so the lens is a hard and flexible and transparent round convex tissue. But what do we have here? Well, notice that it's bending. All these are light rays, or rays of light. And notice that it's actually changing angles and moving through and actually changing its angles. And now that all this light is being condensed onto one point. So this used to be advertised on Instagram like 1 or 2 years ago. And I used to see this like, hey, take these amazing photos, and it's just a clear plastic ball. But they're saying like, take this amazing scenic shots with this plastic ball, or I don't know if it's plastic or glass, whatever. It's way overpriced. It was something like $100 if I remember. I was like, what, whatever. But the interesting thing is what I'm getting at here is that the curvature of this convex lens. So a convex lens is a lens that instead of being flat, it bulges out like this. So when you have something that's like extremely convex, like the sphere right here, it's actually concentrating all this light from its surrounding and focusing it on a smaller area. So this is what I want you to get from this. When you have a convex lens, it tends to sharpen the focus. So if you have something that's blurry, these convex lenses help to sharpen it. Now, why does this happen? It happens due to something called light refraction. If you've already taken physics, I forgot if it was like in first or second semester intro physics, they do cover this. But this is one steel continuous straw. But what do we notice here? It looks like there's a break in the straw. Or you can do this at home with your own glass, and you probably saw this when you did in like elementary school or whatnot. But it's due to this light refraction. This is why it looks like it's not one continuous object, but it's due to light being bent by the differences in how light is being bent by air and the glass or the water in the glass that we see this different appearance. So refraction refers to just this general ability of light being able to be bent when passing from one substance to another. So when we're talking about lenses, well, light is not only passing through the lens of your eye. Well, the lens of your eye does do refraction, but also refracts through your cornea as well. So as your light enters your eye and passes through the layers of your eye and finally hits the retina, it's undergoing various degrees of refraction just by traveling through the tissues of your eye and tissues, water, and humors of your eye. Yeah, so this is why this guy, he's not actually decapitated, it's due to light refraction. Okay, we talked about the lens, and we talked about what convex is. So again, a lens, well, say the convex means bulging outwards, right? So what would a completely flat lens look like? Well, a completely flat lens are like I had a friend, he just thought glasses. I mean, I've wore contact lenses and glasses since elementary school, but he wore glasses because he looks cool. It thinks it looks cool, so it's non-prescription. I was so irritated at him. Like, I wish I didn't have any glasses, but anyway. So his non-prescription glasses, they have lenses, but they don't actually have any sort of curvature, so they just let light through. Otherwise, his when he puts it on, it will look distorted. Whereas convex lenses, as we established earlier, they condense light and they kind of focus something on a point. Whereas concave, so instead of actually bulging out, notice that these are curving inwards. So these concave, instead of focusing something, what do you think they're going to do? They're going to do the exact opposite of a convex lens. So it's actually going to start to spread out these rays of light instead of actually focusing them on a point. Okay, let's talk about accommodation. So your lens, despite being pretty tough, is able to change its shape. So it can actually, well, it won't get completely flat like that completely flat example we saw earlier, but it can actually round and it can kind of flatten out as well. So as it gets more flattened, it doesn't focus on a smaller area, but if it gets rounder, it's going to sharpen the focus and actually condense it on a shorter or a smaller area. Well, what happens if you have something called presbyopia? So then this is something we call about the loss of it. So presbyopia is the inability, or actually or I should say, the loss of ability to accommodate the focus of the lens of your eye. So like when you're looking at something like, or if you go outside, you can like focus your eyes and look at your finger and kind of sharpen your finger, but the surroundings in the background will end up getting blurry, right? But what if you look in the distance and stop looking at your finger? Your finger gets blurry, but objects in the distance, they start to look sharper. So that's accommodation. When you have presbyopia, you start to lose the ability to accommodate and focus. And I have a friend, like he's in his 50s now, and then it's funny because like whenever he goes to the restaurant and he refuses to get glasses, but whenever he has like some sort of the menu is like he always takes the menu and he always if you ever see, and actually if you go, or when restaurants open again, what happens is that you might see people like this, like they're going like this, like when they look at a menu, they're like that. But why are they kind of doing that? Well, if they're unable to accommodate and change the shape of their lens, they can't really focus on that menu in front of them. So yeah, that's what condition we call presbyopia. It's due to stiffness that occurs naturally with age. Like I have an optometrist, I don't think he's an optometrist anymore, but he always used to give me crap. Like when he was an optometrist, he would say like, well, you'll be knocking at my door when you reach 45 or 40 or 45 because that's when you start to develop it and it hits everybody. I'm like, oh shit, stop reminding me of that. But yeah, so that's the natural process. Okay, now let's talk about another condition affecting the eye. So cataracts is another condition that affects the lens of the eye. But instead of it being a stiffening of the lens with age, what we have here with cataracts is that, okay, right now we are seeing normal vision. But what does someone with cataracts see? Maybe they'll see it starting to get a little more hazier, but you also see a slight discoloration as well. Another thing that also happens with age, besides stiffness of the eye or the lens, is this kind of gradual yellowing and also clouding of the lens as we age. So this is what we call cataracts. And how do you treat cataracts? Well, this tissue, it's hard to clear it up and make it and uncolor it from that yellow color. So what they often do as we age is that it gets worse in terms of getting hazier and more yellower or discolored. So cataracts in general is a clouding discoloration of the lens, and it's just like presbyopia, it's a natural occurrence. So what do they do during cataract surgery? They actually use this probe to break up the old yellow and cloudy tissue and replace an artificial lens. So I think my mom had this surgery, but it takes a while because again, what are they doing? They're taking a tissue, they're putting an artificial lens, and everything needs to heal, and then your neurons and your neural control of your lens and your ciliary muscle, they need to kind of adapt so that you're actually able to focus. So it does take some getting used to, supposedly.